Thanks for listening. This is Brian Hurley from Business Performance Improvement. The podcast Lean Six Sigma Bursts are short lessons, comments, Q&A, and insights. If you have a question, send your question through the Anchor app, and we might feature you on a future episode. Or contact me at biz-pi.com. In this podcast, I share part of a presentation I gave for the Lean Portland Happy Hour. This was around statistical process control and the Western Electric or Nelson rules for out-of-control conditions. I talked about a segment around how Toyota does or does not use control charts. And then there's a follow-on question from Maria who asks about controlling outputs versus inputs and referencing back to the section around Toyota. So I tied them together. I'll also link to the full video presentation from that training. I'll probably also take some other clips out of that presentation and use those as podcasts in the future. If you have other topics you'd like to hear about, also please reach out. And thanks for listening. Let me pause for a moment to tell you about our sponsor, Creative Safety Supply. Creative Safety Supply is a great resource for free guides, infographics, and continuous improvement tools. I recommend starting with their 5S guide. It includes breakdowns of the 5 pillars, ways to begin implementing 5S, and even organization tips and color charts. From red tags to floor markings, it's all there. Download it for free at creativesafetysupply.com/5S. Toyota is kind of the model for a company that does process improvement very well. And their TPS system is modeled by many different companies. Do they use control charts? They used to quite a bit. So Dr. Deming was a big proponent of control charts, and he is the person most responsible and most credited with turning around the manufacturing in Japan. They love him over there, and he turned them into a powerhouse, so much that it created a whole revolution in the US trying to figure out what do we do to catch up. And that's where Six Sigma came from, was Motorola had to come up with a program to match what they were getting from their competitors in Japan. And control charts and all the Six Sigma stuff were part of that. So during those workshops, he taught SPC as a core concept. And there's examples and pictures and a couple articles I found that show pictures and diagrams of control charts being used in the 50s and 60s. And then it started to move into more machine controlled by the 80s. But what you don't see a lot, or what people were saying, is there's not a lot of evidence of control charts being used today. And I think what that is because of this quote down here by Art Smalley. He says, Toyota worked for decades to remove the common sources of variation for common and special causes, so much that their process controls were very high. And there's almost a transformation you go through with a control chart. You start without having any charts, then you add your control chart, then you find your special causes, then you start controlling your common cause a little bit, then you cut back your sampling. So in that video, they were sampling potato chips, I think, every hour. If your process starts getting really good, you should go every 2 hours. And if that continues to look pretty good, go every 4 hours, maybe once a day, and maybe 1 bin a day instead of 3. And you start cutting back so much that you're like, why are we doing this if our process is stable and in control? Probably because we have all the upfront controls in place that's keeping it in control. So tracking at the end doesn't make any sense now. We can quit doing this. And so you might actually get rid of or eliminate the chart at some point. And so you've almost come full circle. But going into a company, you don't know if they've already gone through the whole cycle and don't need the chart anymore, or if they've never began in the first place. So I usually assume they've never begun. But I would believe that Toyota's probably gone pretty full circle, and they don't need it very much because they have a lot of rigor around their standards and their structure and process controls. But for the rest of us, I think we probably have opportunities to use this kind of charts.
So yeah, I agree that like a lot of times just to start tracking some data, seeing the trends can be really powerful to people understand like how a process is performing.
Yep.
I might be opening a can of worms here, but I'm thinking of like, how do you choose? Like we look at these examples as dots, right? how do you choose what thing you're measuring? Because there's often, and maybe we can use the circuit boards as a example, that after the thing is printed and soldered and all the parts are placed, it's too late.
Yep.
So, if you're talking now, I'm mixing examples to go back to semiconductors, that there's 200 different control charts that are probably leading variables into what might result in a defective unit at the end.
Yeah. So I've heard this other term used, that like the handbook called statistical quality control. I've also heard that SQC is measuring the output of your process and monitoring it, like the salt content in the video. And then SPC would be monitoring an input factor, like the temperature of the oven as it's going through, which is more like inline as it's happening, or the conveyor speed of that little hopper as it's sifting the potato chips down the line. You're tracking the vibration of that to make sure that it's moving the chips properly and separating them out and stuff like that. So the goal is ultimately to get to where you're doing inputs to your process and monitoring that.
Yeah.
It's after the fact of the salt content is too late, but it could still flag process issues that, let's say their salt content in the video had gone up. They could go back and say, oh, there's something wrong with our hopper. It's not been cleaned or preventive maintenance done on it like it's supposed to. It's getting clogged, and now we're getting clumps of these salt getting dumped in there, or it's starting, too much moisture is getting in there, and now too much salt's getting in, and that's spiking our end result. So I usually say, like, let's have like some key things we're tracking on the back end, but ultimately we should always be trying to get back to process inputs. What's going into the process and what's happening during the process that we can actually control. Because you're right, it's too late at the end, but at least it's better than the customer finding out and saying, oh, this bag of chips
After the
tastes
fact,
awful.
Well, and I'm thinking back to that one point that you had on that slide with the full cycle on the Toyota slide, where we don't have a chart, we add a chart, we fix all the things, and then there's no chart again. I could also see that moving around on the inputs and the outputs, like, because you're in the beginning, you're kind of searching for the right thing to measure around, is it the salt? Is it the conveyor speed?
This common cause, controlling the common cause. That is really that process inputs, is saying before, every time we see this chart act up, it's because this one thing doesn't get done right, or we forget to clean out this trap, or we forget to, switch out this tool, or we have been pushing this machine longer than it's supposed to. And here we go. It's starting to have problems again. And so, you get into now the inputs that you're controlling better.
Yep.
Lean6sigmadefinition.com has a list of glossary items about popular process improvement terms, along with the history of Lean and Six Sigma methods, and key influencers like Dr. Edward Stemming, Henry Ford, Taiichi Ono, Shigeo Shingo, and many more. You can also learn how to access affordable Lean and Six Sigma training and certification. Visit Lean6sigmadefinition.com.